Back, students, to the chemical reaction portion of Unit 4. This is the fun stuff. This is where we get to see how things change chemically. Specifically in this unit, we're going to deal with ionic compounds in solution and how they react. So we're going to introduce two new types, overarching categories of chemical reactions. We deal in general chemistry with 5 major umbrella groups of reactions. Last few units, we concentrated on synthesis and decomposition reactions. We will review those here today. This unit, we're going to talk about our replacement or displacement reactions. You may hear it in one of two ways. That is where we see mostly of our ionic compounds. And the next unit, we'll get into our combustion reactions. In our synthesis reactions, we are going to see multiple reactants. In this example, we have 2, carbon and oxygen, forming one product. So if you see a chemical equation where there is only one product, products being on the right side of the arrow, then you know you have a synthesis reaction. Let's take a look at a picture that exemplifies this. Here we have the reaction between our metal, potassium, which you can see on the left, see it all organized together, which means it is in the solid form, reacting with our chlorine gas. Chlorine is a diatomic molecule, that's why you see 2 atoms together, and that fuzzy part shows you that they're moving around very fast, and there's a separation, so it's a gas. This is actually an explosive reaction, so if we're going to tie this to our kinetic theory, it is a highly exothermic reaction, and when the two combine, they form one product, which, as you can see, is in the solid form, very organized, and that solid is a ionic compound referred to as potassium chloride. In that previous slide, you may have seen small subscripts that had either S, AQ, or G in parentheses. What do those mean? That gives us an idea of the state of matter that particular element or compound is in. So you saw potassium had an S after it. That means it was a solid. You saw the chlorine gas had a G after it. That means it was in the gas state of matter. You may also see AQ. That means it is a dissolved solution. These are important because we need to know if they're changing states of matter in addition to whether or not they're changing chemically. The second reaction that we have looked at is a decomposition. It is the opposite of synthesis. It is the falling apart of a compound. And so in this particular example, we've got sodium chloride. This would be in the solid form. Falling apart to create chlorine gas and sodium. It is represented with only one reactant, so one thing on the left-hand side of that arrow, forming multiple products. In this example, 2 different products. Here is a pictorial example of that. So here I have mercury 2 oxide, solid form. You can see the different atoms of mercury and oxygen all combined together into an ionic compound. And when they decompose, this would be an endothermic reaction, they're going to create mercury, liquid mercury, there's that little L, and gaseous oxygen. So now we're going to get into our new types of chemical reactions. Both of them are displacement or replacement, you can call it either one, reactions. The first is going to be a single displacement or single replacement. In this instance, you have an element, for this example we're using zinc, that's going to replace or get rid of, displace a like element in a compound. So since zinc is a metal, it's going to displace and then replace the copper in that compound between copper and chloride. When it displaces it, that metal ion then goes back to its elemental form. So to recognize a single displacement, on the reactant side, you're going to have a compound, an ionic compound that has both a metal and a nonmetal. And you're going to have an element, and that element can either be a metal or a nonmetal. What will form is a new ionic compound where one of the elements in the previous compound has been brought back to its elemental form. Here's a visual of what that might look like. I've got lithium solid in a water solution. That lithium is actually going to replace the hydrogen in that compound to form lithium hydroxide, and what will be released is hydrogen gas. Hydrogen will be released in its elemental form. Our double displacement or double replacement is very similar to the single replacement, but it's between two compounds. And in those two compounds, like elements are going to switch places. So the metals will switch places, or the nonmetals will switch places. In this example, I've got calcium is going to replace magnesium, and then magnesium is going to replace calcium. So you have to have two compounds on both sides of the equation, where either the metals are switching places or the nonmetals are switching places. So let's pause and go into the practice section of our packet and try to classify those reactions as either single replacement, double replacement, synthesis, or decomposition. Thank you.